All right, if I want to find well, first of all, I need to find a common denominator to add and subtract fractions. That's not even just for things with x's, that's in general. Like a rule of adding and subtracting fractions is you need to have a common denominator. This denominator is just a little bit more complicated because it's a polynomial, not just a single number. The easiest way to find a common denominator is to take your existing denominators and multiply them together. But even before I do that, I'm going to factor this one just to check it, because sometimes it's not the same. Usually it is. So factoring this one, what multiplies to -8 and adds to 2 is +4 and -2. So the easiest way to find your common denominator is to multiply your existing denominators together. So that's the first denominator. This is the second denominator. And then the third denominator looks like this. So I'm multiplying all my denominators together. However, if you have repeated factors, don't use the repeats. I'm not going to use an x plus 4 twice and an x minus 2 twice. There's no need to repeat a factor that's already there. They already have that in common. So my common factor is going to be x minus 2, x plus 4. So I want to change this denominator to x minus 2, x plus 4. So in order to do that, I ask myself, what does this denominator have that this denominator doesn't? I added in this x plus 4 down here that this didn't have. So I need to put an x plus 4 to its numerator. And its existing numerator is x plus 3. So I'm keeping the numerator the same, and then I'm bringing in this new part of the denominator. And why this makes sense is, technically these would cancel out and I'd be right back where I started. So I'm keeping the fraction equivalent. For this one, I want to make my denominator x plus 4, x minus 2, because I decided that that's what my common denominator was. I'm going to keep the existing numerator the same. And I'm going to ask myself, what does this denominator have that this one doesn't? This one has an x minus 2 and this one doesn't. So I have to add that x minus 2 to the top. This way, if the x minus 2 canceled out, I'd be right back to where I started. For the last fraction, I want my common denominator to be x plus 4, x minus 2. And I ask myself, what does this denominator have that this one doesn't? And the answer is nothing. This denominator has everything that this one does, which means I'm not going to change this numerator. Are we starting to remember that maybe a little bit? Once you have your common denominator, the common denominator becomes irrelevant. Once I have it, I don't need it anymore. So what I'm going to do is I'm going to multiply the tops. X times x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. Right? I'm distributing all of the stuff in that first numerator. In the second numerator, x, so I'm adding. X times x is x squared. X times -2 is -2x. 5 times x is 5x. And 5 times -2 is -10. I don't need to multiply anything in this numerator, so I'm just keeping it the same. Once you have a common denominator, you no longer need it, so I'm not going to write it anymore. We could cross multiply here, and all it's going to end up doing is canceling each other out. So I don't need to write it. From here, I'm going to combine my like terms. So x squared and x squared is 2x squared. 4 and 3 is 7. 7 minus 2 is 5, and 5 plus 5 is 10x, and 12 minus 10 is +2. In order to solve this problem, I need it to be equal to 0. That way I can either factor or use the quadratic formula. But to use either of those, you need the equation to equal 0. So I am going to bring this over here, and I'm just writing it vertically with its like term, so combining that's easier. So I'm combining that with its like term, so it's easier. So I've got 2x squared minus 11x minus 21 equals 0. From here, you could check the discriminant to see if it's a perfect square. I think it is. I don't know if any checks. I think this is factorable. But if you start to try to factor it and you can't factor it, then just use the quadratic formula. You don't have to memorize the quadratic formula. You will have a sheet in front of you that has the quadratic formula on it. But this one we can factor. So I am going to just bring this up here. 2x squared minus 11x minus 21 equals 0. It's factored by grouping because that's a 2. 2 times negative 21 is negative 42. So I'm looking for something that multiplies to negative 42 and adds to negative 11. Those numbers are negative 14 and 3. Okay, so I'm just doing factor by grouping. That negative 42 is coming from this times this. In your calculator, you can do a negative 42 divided by x. And look in the table for two things side by side. That if you put a multiplication symbol between them, sorry, 3, not 11. If you put a multiplication symbol between them, you get negative. If you put an addition symbol between them, you get negative 11. Factor by grouping, you take out the common denominator of the first 2 and the second 2. So I'm going to factor out a 2x by dividing each of these terms by 2x. And I'm going to divide out a 3 by dividing each of these numbers by 3. You should end up with the same factor in your parentheses. So factored form for this one is 2x plus 3, x minus 7 equals 0. So now I'm going to be able to find my two answers pretty easily. Opposite of this, x equals minus 3 divided by 2. And opposite of this, x equals 7. In addition to the solutions, you need the restrictions. The restrictions come from your common denominator, right? What can't x be? X can't be 2, and x can't be negative 4. Sometimes a restriction matches a solution, and that's called an extraneous solution. And sometimes it doesn't. In this case, none of these match these. But if we factored and we got one of the answers to be 2, then I would write extraneous next to 2, because x can't be 2. Hopefully you remember that, okay? If you don't, we're going to have a lot of time to practice these today. But I just thought maybe a refresher would help, okay? So we are reviewing this unit. This unit consisted of just half of this, like no equal to sign. You finding common denominators and not having to solve. Then we did multiplication and division, where you factored everything and just saw what canceled out. We did division, where you had to flip, factor everything and see what canceled out. So today, these are the things we're reviewing. Here's the things that you need to be able to do on your final. Can you factor? Specifically perfect cubes, because that's the one I think we struggle with the most. So can I factor a differences of perfect cubes? Can I factor a sum of perfect cubes? Can I solve an equation using the quadratic formula? I'm talking a basic equation using the quadratic formula. X squared plus 6x plus 5 equals 0. Can use the quadratic formula. I can simplify a rational expression with addition, subtraction, multiplication, and division. This is not solving. There's going to be no equal to sign here. It's just, can you find a common denominator? Can you factor and cancel? I can find restrictions. Do you notice at the bottom equal to 0 and say x can't be this? I can solve a rational equation like we just did on the warm-up. I can find an extraneous solution. We didn't do that on the warm-up, but it could have happened on the warm-up. So this is about 1/3 of your midterm, these questions. So today we're going to do some practice with those specific types, but there is a typo in your packet. So if you could go to page 3 of your packet, the next page, I think this is a 4, but it should be a 2. Is it a 4 in your packet?
It's a 6.
Oh, it's a 6. Okay, cross out the 6. It needs to be a 2 so that you can factor it. I want you to take out a GCF, and I want that GCF to end up canceling with something else. If it's a 6, it's not going to work out. So I want you to change that. And then from there, the rest of the class is gonna be self-paced. I felt like instead of me being up here like reteaching you and boring the life out of you, you kind of going at your own pace. So the problems on page 3 and 4 are all specific to this first unit. You can see in the first column, there's a question, and then in the second column, there's space for that answer. 3 and 4 have the same type of format. The answers to these are all around the room, so that I had space to like really go through all the steps. The pre-calc stuff is white. The pink and yellow is my freshman class. They're doing something similar, okay? So you can stand up and do the problem around the room just to move around. If you don't want to stand up, the problem's written right there on the paper in front of you. You can do it. Eventually, you're going to have to get up to check your answers. If any of you want me to just sit and do page 3 and 4 with you, I'm happy to do that, okay? I just don't want to do that for everybody because I think that that would be boring, all right? So you can either do it independently, you can work with a friend, or if you want to work with me, I'll take a little group up here and I'll do those problems too. Everybody understand what we're doing? All right, if you finish early, the actual traditional pencil and paper test review guide is page 5 through 7 in here. So if you want additional practice aside from these, that's what you can do. All right, anybody want me to work through page 3 and 4 with them? All right, if you change your mind, let me know.
Wait, Miss Diamond.
What's up?